Hey guys, welcome back to another lesson. Today we're going to be talking about composition of functions part 2. This is a continuation from part 1. In part 1 we discussed just basic operations with functions, how domain and ranges can be affected by those operations on functions, specifically division, right? And then we talked about what is a composition. Okay, we start talking about this notation and what it means. And we did one example where we did some relations, okay, which are functions. But we used a relation specifically just to kind of illustrate how to go about evaluating this guy. So today, we're going to actually use expressions instead of ordered pairs this time to evaluate f of g of x, that's not fog, that's how we say it, and g of f of x. Okay, so we're going to go ahead and do that. We'll do one word problem and then that will be it for part 2 of this lesson, okay? There's a lot of other things I would like to discuss with this, but I'm just trying to keep this as compact as possible for right now, especially at the time of me recording it. It's the end of the year, end of a pandemic year for school, and I think we're all kind of burned out. So let's go ahead and jump right into it. So I want to figure out these two guys. So f of g of x and g of f of x, okay? So let's take a look at f of g of x. And I'm going to write it using a different notation, okay? This is the same thing, oops. There we go. This is the same thing as this guy right here, okay? They're identical. Now, what that implies is I'm going to plug this equation. Remember, we always work from the inside outward, okay? I'm going to plug this equation into here for every x value. Here's what it's going to look like notation-wise. So the f of g of what? 2x minus 1? So actually, technically, let me erase that. It'll be f of 2x minus 1. That's what I'm going to plug into. So, using a different color, this guy right here, I'm going to plug in for each x value. Okay? Let's go ahead and do that. So we have 3 times 2x minus 1 squared minus 2x minus 1 plus 4. Now, let's go ahead and evaluate this one, okay? And funny thing, do this off to the side. Sorry about this. We could do this in our head, but since this is a lesson video, I want to make sure we can all follow together. So let's do a quick little math doodle over here, okay? 2x minus 1, if we're squaring it, looks like this. So 2x and 2x would be a 4x squared, right? 2x minus a negative 1, so it's negative 2x. This would be another negative 2x when I multiply it. So it would be negative 4x. Negative 1 times negative 1 is a positive 1. I'm going to go ahead and distribute the negative here. Negative 2x plus 1, and then plus 4 right after that. Okay. Oh, forgot the parentheses here, because it's still 3 times that guy. It's 3 times that polynomial. Multiply the 3, I get 12x squared minus 12x plus 3 minus 2x plus 5. I'm going to combine the 1 and 4 together. Then to finish this up, I would have 12x squared minus 14x plus 8. That is what f of g of x is. Okay? When you combine those together. The calculation, from my perspective, isn't a difficult thing. It's knowing what this notation means. Mathematics is a language, so knowing how to read this language is important. When you see something like this, you want to know what that means, okay? And it means I'm going to plug whatever function this is into the function that's on the outside of this parentheses, okay? Now, real quick, let's do the other one, all right? Let's do g of f of x. Now, that would be me plugging in 3x squared minus x plus 4. I'm going to plug this guy into here, that x value, okay? Now, would we expect these to be the same? They could be. In fact, if they are the same, they're technically called inverses, but that's a different lesson for another time. But it is a very unique situation when they are the same. Okay. So anyway, let's go ahead and go through this. So let's see. Let me just put an equal sign there. We have 2 times f of x, right? Minus 1. I'm going to go ahead and multiply 2 to everything. 6x squared minus 2x plus 8 minus 1. For my last step, combine like terms, 6x squared. This would be still, what, minus 2x plus 7. So this up here would be g of f of x. Okay? So right now, probably as you expect, both of these would be different, just depending on the function, obviously. They could be the same, and that'd be for like a different lesson. I said that already, but anyway, that's calculating those guys. Okay, plug in a function, set up another function. Now, here's the deal. If I had, let's bring this board back. If I had this, let's say I added 3 functions to the mix, what would that look like? Well, it would just be this. Okay? You would work your way inside to the outside. You would start here first. You would plug this function into G. And then whatever that simplifies down to, you would plug this guy into F. Just kind of work your way out. Okay? And that can happen. We're just dealing with 2 functions currently. But in the future, you could work with a lot more than that. Just depends. All right. Questions, concerns, dilemmas? Nah, you guys are okay. I know you are. Okay. Everyone's favorite. It's a word problem. Hooray! And let me just get my calculator. Okay, I'm going to need that for this problem, and I suggest you do the same. Let's go ahead and read this together. So you have $100 deducted from every pay for retirement. Okay, not bad. I mean, you probably should put more than $100 away. Retirement nowadays is very important, especially the older you get. You have to start thinking about that. Your state income tax is 4%. You can earn $1,500 every pay period. Find the difference in net income if your retirement is taken out before or after taxes. We're going to have 2 situations and we're going to make a comparison, okay? So in other words, should I take the $100 out now, then do the 4% tax? Or do the 4% tax first and then take $100 out? Okay, what would be better? And this is important for a lot of people getting into that, your main career, and you're talking about retirement and insurance and all kinds of other stuff when you get out of college or just out of high school. This is different things you have to think about if you have an option to do this. Okay, I'm going to create 2 functions. We'll name the first one R for retirement, and the X value is going to be my income. So my income's $1,500, but if my income changed, then I want to make sure that I can, adapt my functions to that. Here's my retirement function. So I'm going to take what I earn, and I'm going to subtract $100, and that's it. Okay, very simple, straightforward function. Now, the taxes, okay, well, I want to take 4%, right? And notice, these are separate right now. I will combine these later, but these are 2 separate functions. I'm not worried about combining them yet. So T for taxes, and what I'm going to do is I'm going to take my income and subtract the 4% of my income for that tax, okay? So 4% would be what, 0.04? And whatever 4% of my income is, I'm going to take it away from my total income. Okay, so there's that guy. Just be careful. In past, a lot of people have been doing this. They say, oh, it's just 4% of what your income is. Well, no. What would it be after that 4% is taken out? So you do have to make sure you subtract that out. Okay? All right. So, 2 situations. First one, let's do this before taxes are taken out. Okay? We're going to come up with a function that would represent this. If before taxes are taken out, that means we're doing this guy first, right? R of x would be first. If I'm making a composite function, that means r of x has to be in the center or in the parentheses, and what's on the outside would be your taxes. Okay, so we're going to do the retirement first, then take your taxes out. Okay, so that's what this is. So, looking at this notation, r of x, okay, we're going to plug in what? Our income of $1,500 in for this guy. Okay, and let me just adjust the camera a little bit. Perfect. So I'm going to plug 1,500 into r. R is this guy. So 1,500 minus 100 is 1,400. Okay, so I have $1,400 left after that deduction. And what I'm going to do now is take my income tax out. Okay, state income tax, sorry. So that's going to be 1,400 minus 1,400 times the 4%. Okay, so it's this guy right up here. Now I'm going to type that in my calculator. I'm going to see for myself what that is, and I highly encourage you to do the same. Okay. And we get 1,300. Oh wow, 1,344. Okay, so that's what he's going to be taking in. Now there's other deductions, obviously, but this is just very basic. We're not going to put other deductions in. So that's before taxes, that's what he's earning. Now, the second situation, what if we took the taxes out first? So this would be what? After taxes. Okay, so we're going to take the taxes out first. That means my composite function is going to be flipped. So that means r is on the outside, t would be on the inside here. Okay. All right, now what we're going to do is I'm going to plug 1,500 into here. Okay, so I'm going to plug 1,500 in for the tax function, and I'm going to do that right now. Okay. And I get 1,440. Okay. And that amount, I'm now going to go ahead and take out my retirement, which is subtracting 100 out of it. Okay, so our final take-home pay would be 1,340. So what's the difference here? Well, if you notice, the difference is just going to be $4. Okay, $4 difference. Now, is that significant? Well, put it this way. It could be. If you're getting paid twice a month, that's $8. $8 over a year would be, what, $96 there? So looking at $96 a year doesn't sound like that much, but if you're investing, $96 could give you a lot more money, depending on how you invest. So I guess it's interpretation there. But you, yourself, would get more money if you take the retirement out first and then take your income tax out, or state income tax. Okay? Alrighty, so that's it, guys. That is composite functions. So there's an example with equations, which isn't too bad, right? It's just substituting x for an entire expression, which is more common than what you think. And then we did an example where we could use composite functions. Okay, from a programming aspect, those of you interested in programming, you could probably see where this could be easily typed into just some sort of software to where you can calculate this, right? Which you probably would imagine already exists, but you can kind of get a little bit of an insight as to how they do that. Okay, they're creating stuff like this, programming that algorithm to take the input values that you give it and to do those calculations. So it's really cool when you're looking at it from a computer science standpoint. That's it. We're done. So I hope you all are doing well. My last lesson video for the year, but obviously I'll be updating, changing things throughout the year. So other than that, have a great day, guys, and I will see you all in the next lesson video. Take care.